like to talk about event horizons. An event horizon is a horizon where you can't see or predict an event. I was thinking about event horizons a lot with models and what the present science was in terms of predicting hurricanes, when and where they would be at a given time. And the best models are good for about 5 days. But then I started thinking about what is out there to control or modulate climate. You have to be able to assume that whatever it is that's going on works well into the future and therefore is actually more predictable than the physical inputs into the system itself. So let me give you an example. We live here in the Northwest where there are giant redwood trees. These trees are, in some instances, hundreds and hundreds and hundreds of years old and can grow up to 300 feet. They're found along the coast, and the climate here is very rainy for a short period of time, and then it stops, and the Pacific high sets in. These wonderful trees have adopted the ability to take a foggy condition, which is prevalent along the coast, and convert that fog with its needles and capture it and cause it to drip down on the tree itself. Up to 15 inches a year of rainfall is added to the tree's root system just based on the design of the tree itself. So we find that a lot in nature. But that isn't precisely what I was looking for. Another example, though, along the same lines is, let's say I wanted to predict at 5 in the morning whether there would be rain in my front yard. Well, given the present modeling and way of understanding climate that we have, there's really no way for us to predict what is going to be in my front yard, say 10 or 15 years from now. However, if I were to plant a tree in my front yard, and that tree was capable of collecting dew in the morning, then in a way I could predict that my front yard would indeed, at some distant point in the future, have moisture associated with it. Well, along with those ideas, this idea of a living Earth has come into view. And what precisely must nature do to control its climate conditions? And again, looking at event horizons, I was trying to understand what and where this had to occur. In that context, a scholar by the name of William Gray, who was a hurricane expert, predicted hurricanes based on a factor of rainfall in the Sahel of Africa, or in the African, near the equator of Africa along the west and south coasts. And what his factor basically said was that if there was rainfall 6 full months prior to the hurricane season that was heavy, then that would be a predictor of a heavy hurricane, or more likely that the hurricane season would be heavy. So the question is, how did this particular factor of rainfall in Africa become something that could kind of see over these event horizons and see what was going to happen in the future? Now, a typical thunderstorm lasts maybe 20 minutes. The daytime heating over land, generally speaking, occurs, and then as the afternoon wears on, there's cooling, and then there becomes instability in the air, and you get upwards and downwards motions, and that causes air to that has moisture in it to condense, and you start to get the latent, the phase change energy of the water, and it causes a thunderstorm to occur, and the thunderstorm kind of plays itself out, and within a very short period of time, it's gone. So, in terms of its ability to predict things, you have one little tiny thunderstorm over Africa. How in the world would that particular occurrence allow you to predict something down into the future? That itself would seem the day and the night part of the thunderstorm would seem just by itself to be something that would make it impossible to use that particular occurrence to predict a future event, a huge tropical storm, essentially downflow from that position. But I suspect that Dr. Gray thought that it had to do with synoptic patterns or general circulation patterns that favored thunderstorms over Africa would then, down the road, be predictive of tropical storm activity. Now, I think that this particular way of looking at it, synoptics, actually is incorrect. That there's no possible way that a thunderstorm over Africa could be determinative of general world circulation synoptics. Instead, it would make more sense to actually use the synoptics or the flow pattern numbers themselves as predictive of what you might find down the road in terms of a flow pattern that would favor tropical storms. So, to me, this is in itself a mystery, why the synoptics seem to matter. Over the years, Dr. Gray used the rainfall factors of the Shihil and in Africa, Western Africa, and to some to some significant statistical advantage in his models of what was going to go. And it was backwards correct, too. In other words, he would make a prediction, and then over time he would look back, and it would turn out that it was true, that rainfall over Africa seemed to predict what was going to happen in the Atlantic hurricane season. Well, come the season 2003, and Dr. Gray gave up on his factor, and he no longer included it in his long-term hurricane forecast. And the reason why is because it started to fail him. Now, I looked at that, and I noticed that in Western Africa, in the Niger River, and other major rivers in that area, that the Africans had begun to dam them. And so what you have here from an electric standpoint, if you're looking at climate as electrical and biological, as I am, that when the rainfall came, instead of flowing out into the ocean, where then it increased the amount of carbon content and biological load in those oceans, where the largest storms in the Atlantic began to form, then that began to be predictive, physically predictive, of hurricanes because it enhanced the electrical conditions there. So it's actually, now you can understand why that factor worked, not because of some sort of event that was occurring with thunderstorms that was predictive of long-range flow patterns, but rather because electrical patterns were predicted by the amount of rain that flowed into the rivers that then flowed out into the ocean and increased the carbon dioxide load there. So as it turned out, over time, as deforestation and river conditions improved and the conditions stabilized in terms of flow patterns after the dams had been in place for a number of years, then his factors began to work again. So to me that was a very significant study. Also, more closer to home, very similar pattern has occurred in terms of changes to the Rio, Mississippi, and to the Colorado rivers, and then the Dust Bowl that occurred in the 30s. That Dust Bowl, again, was directly related, in my view, to carbon loads that were interrupted and changed as a result of changes of the major rivers in the United States. Another example occurred near the turn of the last century, around 1903. A large lake formed, well, I want to call it a lake, called the Salton Sea in extreme southern California, when the Colorado River overflowed its banks, and instead of flowing out into the Gulf of California, it flowed to this large inland lake that's brackish and salty. And the resulting tropical storm season in the Atlantic jumped up, at least doubled in relation to this event, time-wise. So you go, what's the connection? Well, the connection is, again, the carbon content in these inland, in these flow basins, decrease when rivers don't flow the materials that they normally do into them. And so as a result, you don't have favorable conditions for tropical storms, which remove carbon content and increase their conductivity and hence make those events more favorable to occur. Well, when they're not occurring in the eastern Pacific, tropical storms that is, they are not an impedance event. They're not a low impedance location for charges to accumulate from thunderstorms over the United States and over the continental United States and Mexico and South America. And so those charges are available then to go to other locations. In this particular case, they enhance the tropical storm season in the Atlantic. Another example, again, recent changes to Lake Mead and to water change usage of the Colorado to Arizona occurred here along with the construction of a new dam in western central Mexico. And all these particular river changes are very significant in terms particularly of regional electrical conditions and the amount of carbon available in these basins where these tropical storms exist, which then affect storm patterns, particularly in the United States, with the active season of 2005. So yet another example, in the 80s, huge dams were built in South America. Again, the tropical storm movements and patterns reacted accordingly to river changes there. There were changes to the Orinoco River in South America, also very interesting tropical storm movements in relation to those particular changes. So what we're doing to our rivers is very predictive then of what is occurring with these tropical storms and with global electrical conditions which follow from that. What we do know is the Earth's magnetic field has weakened about 8% over the last 100 years and about 10% over the last 150 years. We know what the Earth's magnetic field's orientation were by, of all things, ship log patterns of what the magnetic field orientation is with comparison to what the star charting of geological north is. And that pattern, those ship records exist, and looking back over time, it's very clear that the Earth's magnetic field is weakening. The actual location of the geometric, the electrical, the Earth's magnetic field north actually moves as much as 40 kilometers in a day. And it has moved over time. But the most significant thing seen is that the field itself is weakening.